APU chapter 14.9. So we know the position or location of the APU in our aircraft. This is APU is self-contained unit that makes the aircraft independent of external pneumatic supply and external electric power supply. So it provides both pneumatic supply and electric supply to the aircraft. On ground, it supplies bleed air for starting the engines and for the air conditioning system. It supplies electrical power to the electrical system. On ground, you can take the bleed air for starting the engines and for air conditioning systems, and it supplies electrical power to the electrical system on ground. During the takeoff, it supplies bleed air for the air conditioning system. During takeoff, you cannot take the bleed for the starting of the engine, so it supplies the bleed air for air conditioning system, and it flight, it backup the electrical system, it backups the air conditioning system, and it can use for start the engine in flight. These are the functions APU can done during the on ground during the takeoff and in flight. This is the prototype of engine. APU is the basic element of the APU is a single shaft turbine. Delivers mechanical shaft power for driving the accessory gearbox. Gearbox is here. Electrical generator, starter, etc. and produce bleed air. Engine starting and pneumatic supply. Bleed air for engine starting and pneumatic supply. So two type of compressor we will be seeing in this: load compressor and normal compressor. When APU is working but load compressor is not working, you cannot have the bleed from the APU. APU is serviceable, but load compressor is not working. In that case, you cannot have the bleed from the APU. When load compressor is working, at that time only you can have the bleed air from the APU. Load compressor is must to take the bleed from the APU. So if you see this bleed is taken from the bleed compressor. This is the, otherwise all the parts are similar to the engine: turbine, combustion chamber, fuel nozzles, surge control valve and APU bleed valve. This is the flap motor for opening and closing of the flap. So this is the prototype of engine, main engine. ECB is their electronic control box. Like headache in engine, you will be having ECB in APU, electronic control box. ECB is taking power from DC bad bus. ECB is taking power from DC bad bus. If DC bad bus is not working, ECB you don't have the APU through the ECB. So if DC bad is must. So these are the functions what the ECB does. Sequences the start and monitors it. When you are starting the APU, at that time it will sequence the start. There are certain procedures. We will see that how to normal procedure and shutdown procedure, starting procedure and shutdown procedure for the APU given in the manual. Monitor speed, temperature and bleed air. So ECB monitors speed, temperature and bleed air. Sequences the shutdown. Sequences the shutdown, sequences the start, sequences the shutdown, controls the automatic shutdown. If there is any abnormalities in the APU, at that time it gets automatically shut down. That will be controlled by the ECB, electronic control box. So electronic control box do all this function. Inlet guide vane control bleed air flow by changing the IGV position with the help of the fuel pressure powered actuator. ECB controls the actuator in response to the aircraft demand. ECB, what ECB does, it controls the actuator in response to the aircraft demand, and actuator is making the position of inlet guide vane. So these are all the function of the ECB, electronic control box. So as I told you, it is like the headache in engine. The ECB is there in the APU. APU may be started by using APU starting methods. How the APU can be started? APU may be started by using electrical power supplied by the aircraft batteries, an external source, and the engine generator source. These are the three power sources. from where you can operate the APU. The air ka batteries, external source and the engine generator source. APU starting and shutdown. There are 6 methods has been discussed here. So we will see each and every individual one, how the starting and shutdown of the engine APU will be done. One is normal start sequence. We will see that normal start sequence, how the normal start will be done. Normal shutdown sequence. Auto shut-off, there are almost 20 to 25 conditions when the auto shut-off of the APU will be done by the UCB. That we will see what are the conditions when the auto shut-off will be done. Auto shutdown only on ground. So auto shutdown is possible only on ground. Manual emergency shutdown in flight. Fire in flight. Manual emergency shutdown on ground. Manual emergency shutdown on ground. So these are all the 6 sequences. Or these are all the 6 starting and shutdown methods. So each and every individual method we will see. Normal start sequence. Page 1 of 2. Normal start sequence. Press the on switch on the master switch of APU overhead panel. This is the APU overhead panel and master switch is there. Put the on switch on that. Blue on light comes on. There is a blue light which is comes on. Electrical power goes to the APU. ECB performs the power of test. ECB performs the power of test. APU air intake flap opens. APU air intake flap opens. APU fuel isolation valve open. If no fuel pump is running, APU fuel pump operates automatically. Any fuel pump is not running, in that case APU fuel pump operates automatically. APU page appears on ECAM. Flap open indication appears when air inlet flap is fully open on the APU ECAM page. Okay, this indication will be there. Flap open indication will be there on the APU ECAM page. So this is the sequence when you put the master switch of switch on in APU overhead panel. APU can now be started using the start push button switch. There is another switch for starting the APU. APU can be started using the start push button switch. This is the page 2 of 2. Normal start sequence. Select the APU start push button switch to initiate the automatic start sequence. Okay, APU start push button switch. Select the APU start push button switch to initiate the automatic start. Blue on light comes on in the start push button switch. Starter is energized once the flap is open completely. Flap complete open होने के बाद starter is energized. 5 seconds after starter is energized, ignition turns on. When N is 60%, APU starter is de-energized and the ignition is turned on. 2 seconds after N reaches 95% or when N is more than 99.5%, on light on the start push button goes out and AVEL light comes on. AVEL light will be comes on. AVEL indication appears on ECAM APU page. APU AVEL memo is displayed on EWD. APU may be now supply bleed air and power to the aircraft system. So this is the normal start sequence for the APU. Then next is the normal shutdown sequence. How to shut down the APU is, this is the normal shutdown sequence. When APU running is no longer required either for bleed purpose or for electrical purpose, we need to switch it off. Okay, we need to switch it off. Select the APU master switch to switch it off. Master switch to switch it off. Blue on light in the master switch push button extinguishes. AVEL lights on the start push button go out. If APU bleed is being used, APU keeps running for a cooling period of 60 seconds to whatever. If APU during the shutdown sequence and if you are taking APU for providing the bleed air and for taking the bleed air if you are using APU, So it takes certain time for cooling period of 60 seconds to 120 seconds. 1 minute से 2 minutes it will take, it will keep running for 1 to 2 minutes. When cool down period is over, APU shut down and await disappears. When you are taking APU bleed being used, APU bleed being used, 1 to 2 minutes it will be keep running for cooling period. At 7% the air inlet flap closes and flap one indication disappears on APU page. At 7%. The air inlet flap closes and the flap one indication disappears on APU page. This is the normal shutdown sequence for APU. APU auto shut off conditions. These are all the auto shut off conditions. Fault amber light comes on overhead panel and caution appears on the ECAM when automatic shutdown occurs. Automatic shutdown occurs in following cases: low oil pressure, oil temperature, oil system shutdown clog, oil filter. This is related with oil. Air inlet flap close. In that case also it get auto shut off. No flame. Reverse flow. Speed is overspeed, underspeed, no speed, no acceleration, loss of overspeed protection. In such cases also the auto shut off occurs. Loss of EGT thermocouple, EGT over temperature. Failure is there, sensor failure, IGV failure or ECB failure. DC power loss or overcurrent. These are all the conditions when the auto shut off of the APU is happened. Okay, these are all the conditions when the auto shut off the APU is happened. Page 4 or condition 4, APU auto shutdown only on ground. Fire on ground or emergency shutdown. In case of fire in APU compartment. In case of fire in APU compartment, the APU will be auto shutdown only on ground. APU fire warning operate in the cockpit. The abel light goes out. Fault light in the master switch lights up. Fault light in the master switch lights up. Warning at external power panel. External power panel पे warning आ जाएगा. Red APU fire light comes on. A horn in the nose gear bay sounds. APU shut down. APU fire extinguisher discharge automatically 3 seconds after appearance of the fire warning. So these are all the auto shutdown only on ground. When fire on ground or emergency shutdown will appear on the ground. This is the red APU fire light comes on in case of fire is there in the APU. Manual or emergency shutdown in flight. Page 1 of 3. Fire in flight. So if there is a fire in flight, you have to do the manual shutdown in flight. A brief push on the push button switch discharges the fire agent. Script comes on white when the pilot releases the APU fire push button. Okay, this is the fire push button. Discharge comes on amber when the fire extinguisher bottle has lost pressure. Discharge will be comes on here when the fire extinguisher bottle lost its pressure. This is the first of the 3 phase fire in flight. Then page 2 of 3, APU has 1 fire extinguisher bottle with 2 electrically operated skips to discharge its agent. The flight crew controls the discharge of the fire extinguisher bottle from the fire panel. The push button normal position is in and guarded. The red light comes on regardless of the push button position whenever the APU fire warning is activated. Then 3 of 3 is APU agent push button switch comes active when the flight crew releases the APU fire push button. When crew pushes it, the push button is released and send an electrical signal that performs the following for the APU. Shut down the APU, silences the aural warning, arms the script on the APU fire extinguisher, closes the low pressure fuel valve, shut off the APU fuel pump, closes the APU bleed valve and cross bleed, and deactivating the APU generator. So these are all the manual emergency shutdown in flight. The following for the APU can be done when crew pushes it. The push button is released and sent in an electrical signal that perform the following function. This is 5th condition. Then 6th one is manual emergency shutdown on ground. So APU shut off push button on the external power panel is used for manual APU emergency shutdown if an emergency situation is noticed by the ground crew. There is the external power control panel. In that there is the APU shut off push button on the external panel. When crew presses APU shut off push button on the external power panel, APU low pressure fuel shut off valve closes. ECB receives a signal that start the shutdown sequence. ECB receives a signal that start the shutdown sequence. So this is how the manual emergency shutdown on ground can be possible. So these are all the sequence for starting and the shutdown of the APU. APU fire test push button. APU fire test push button. This push button tests the operation of APU fire detection and extinguishing system. This push button tests the operation of the APU fire detection and extinguishing system. When pressed, CRC sounds, master warning light flash, APU fire warning appears on ECAM. On the fire panel, APU fire push button lights up red. The squirt lights comes on white if discharge supplies are available, and the discharge light comes on amber. This is the APU fire test push button. SOP for exterior safety exterior inspection for APU. APU area check. Observe that APU inlet and outlet are clear. This is the exterior inspection can be done. Assess doors close. Air intake condition. Drain condition, no leak. Oil cooler air outlet clear. Exhaust clear. Navigation light condition, fire extinguisher overpressure indication red is in place. So you have to see this fire extinguisher overpressure indication. There is a red disc in the APU area where it is supposed to be in place. Red disc supposed to be in place. SOP for preliminary cockpit preparation. APU fire test or APU start. APU fire push button switch check in and guarded. Agent lights check off. APU fire test push button press and maintain. Check APU fire warning on ECAM plus CRC plus master warning light if AC power available. APU fire push button switch lighted red and squirt light and discharge lights on. This is APU fire test. If the external power push button switch on and light is on, APU master switch push button is on, APU start push button switch is on, wait at least 3 seconds before selecting APU start push button switch. External power push button switch, the flight crew should keep on the external power unit to reduce the APU load, particularly in hot weather condition. If external power push button switch on and light is off, APU master push button switch supposed to be on and APU start push button switch on, Wait at least 3 seconds before selecting APU start pull button switch. When the external power pull button switch is on and light is off. So this is the SOP for preliminary cockpit preparation. Exterior walk around. During exterior inspection, APU compartment access door is closed. Verify the condition of APU air intake. APU exhaust is clear. Verify that APU fire extinguisher overpressure rate is in place. This is how the exterior walkaround can be done in here APU. ये थोड़ा This is the latest environmental envelope. For the APU. APU operation and normal restart limit is 41,000 feet. APU battery restart limit in electrical emergency config is 25,000 feet. APU bleed battery restart limit electrical emergency config. If aircraft is in electrical emergency config, you can have the battery start of the APU below 25,000 feet. हमने देखा था when we are seeing in electrical 250 flight level, you have to come down for starting the APU in case of electrical emergency config. 22,500 feet is bleed air and electrical power can be taken up to minus 2,000 to 22,500. Bleed air and electrical power can be taken from the APU. Above 22,500 to 41,000 feet, only electrical power will be there. No bleed can be taken more than 22,500 feet. APU ground operation limitations is minus 2,000 to 14,500 feet. APU ground operation limit is minus 2,000 to 14,500 feet. Maximum altitude to assist engine start is 20,000. Maximum altitude to assist engine start. Maximum altitude for air conditioning and pressurization single pack operation is 22,500. Maximum altitude for air conditioning and pressurization dual pack operation is 15,000 feet. Maximum altitude for air conditioning and pressurization dual pack operation is 15,000 feet. Use of APU bleed air for wing anti-icing is not permitted. Use of APU bleed air for wing anti-icing is not permitted. So these are all the limitations with respect to the environmental envelope for the APU, operational envelope for the APU. Okay. This is the old one. Oil quantity matches low oil level pulsing. In case of ECB detects low oil level and aircraft is on ground and APU is not running, then it is detected low oil level. ECB detects low oil level. If there is no oil leak, then the remaining oil quantity allows normal APU operation for about 10 hours. Up to 10 hours you can have the APU operation if the low oil level ECB detects and if there is no oil leak. This is the oil quantity motion message, low oil level pulsing. This is what the ECAM APU page will indicate the low oil level. APU limitations, APU EGT display APU EGT in green, green for normal. Amber में यदि it is display APU EGT in amber, if the EGT is more than equal to EGT max minus 33 degrees centigrade. If it is in amber, EGT max minus 33 degrees centigrade. If it is in red, it is more than equal to EGT max. Automatic shutdown begins. Max EGT during start 1120 degrees centigrade above 35,000 feet and 1090 degrees centigrade below 35,000 feet. This is the max EGT during start and APU running is 675 degrees centigrade. The temperature when the APU is running at that time is 675 degrees centigrade. So max EGT during start is 1120 degrees centigrade above 35,000 feet and 1090 degrees centigrade below 35,000 feet. There is note they have mentioned here. ECB calculates EGT max and transmit it to the ECAM. It is a function of N during start and function of ambient temperature when the APU is running. Function of N during start and the function of ambient temperature when the APU is running. This is limitation with respect to the APU EGT. Then APU limitation with respect to the speed N. Green normal when amber is when N is more than equal to 102% and it is red when N is more than equal to 107%. APU limitation with respect to the APU start. After 3 consecutive APU start attempts, the flight crew must wait for 60 minutes before a new start attempt. You have to wait for 60 minutes before a new start attempt. After 3 consecutive APU start attempts, the flight crew must wait for 60 minutes before a new start attempt. APU ground operations minus 2,000 to 14,000 feet, 14,500 feet. That we have seen in operational envelope of the APU. The minimum altitude is minus 2,000 and maximum is 14,500, where you can have the APU ground operation. This is one important circular with respect to the APU 789. इसका number है, number is 789, which must be there in your EFD also. EFD में होगा ये 789. If you search in FDM, you will get this. और onboard library में होगा या फिर FDM में होगा documents में. So this is related with the reliability of APU restart capability for EDTO operation. So they have given certain condition. If you are operating your aircraft in EDTO flight at that time to have the reliability or restart capability of your APU. That need to be proven and supposed to be whatever the data has been recorded supposed to be submitted to DGCA for approval of EDTO, continuation of approval of EDTO for our EDTO certified aircraft in 320 family. What they have mentioned is for continued airworthiness approval of EDTO operation, it is necessary to calculate the APU in-flight start rate on 12 months rolling average basis. Deputy GM EQS will monitor the rate, and if it is dropped down below 95%, an investigation will be initiated to find common causes or system errors in the starting procedure, and same will be reported to DAW, Director of Airworthiness, if it is fall below 95%. What is the procedure is? This is the procedure. In order to fulfill the above requirements and to review the performance of APU, it has been decided after consultation of DGCA that the following procedure shall be followed on first flight of 1st and 15th day of every month. So 2 times in a month on the first flight of the 1st and 15th day of every month on EDTO certified A320 family aircraft. So what are the aircraft we are having EDTO certification? For them it is applicable. Start the engine with APU bleed and shut down APU if the operation is not required prior to takeoff. So you have to, what the sequence you have to do on the 1st and 15th day of every month is, on the first flight, start the engine with APU से start करना engine, and shut down APU if operation is not required prior to takeoff. Restart the APU during climb passing through flight level 100. Restart the APU during climb passing through the flight level 100 and keep it running till the top of the climb or flight level 300, whichever is reached earlier, then shut down APU. Okay, this is the second conditions has been mentioned in this. Restart the APU during climb passing through flight level 100 and keep it running till top of the climb or flight level 300, whichever is reached earlier, then shut down APU. During descent, passing through the flight level 250, start the APU, check the parameters and then shut down the APU. During the descent, passing through the flight level 250, start the APU, check the parameters and then shut down APU. Record in the PDR pilot defect report the observation regarding APU operation in the flight and restart capability. In flight and restart capability. So you have to record this in PDR. Above requirement is reflected in A320 flight report book in the information to pilots and engineer page.
So previous slide once.
Previous slide. This one?
Yes, sir.
Okay. It is there in EMP also. Okay. मिल गया क्या EMP में किसी को?
Yes, sir.
Okay.
Operation
789 लिख दो ऊपर।
Third page in this circular is during an ops audit by DGCA in Camo, Northern region, they were unable to show the said compliance. DGCA has taken a serious view of the issue and have categorically hinted of Airbus withdrawing Air India narrow body Airbus fleet EDTO approval, which will not only be reflecting adversely on the organization but will also cause financial loss due constant of operating the flight on non-EDTO routes. In view of the above, it has been decided to place a sticker in the cockpit in the space above assist or standby horizon indicator to act as a reminder for pilot to carry out APU in-flight restart as required. The format of the stickers is as shown below. APU in-flight restart to be carried out during first flight on 1st and 15th of every month. Report finding in PDR. The above is for trick-lemma unitary pattern. So this is the APU related circular which is given in our APU also. Okay, this is all about the APU. Any doubt, anything you want to discuss about APU? No? लिमिटेशन का ये पेज इम्पोर्टेंट है, इसमें से बहुत सारे क्वेश्चन यू कैन मेक फ्रॉम दिस पेपर को मुश्किल है।